So for the last little, and by the way, this that we're learning today will be on tomorrow's quiz too. Okay, so keep that in mind as well. Okay. I'll call this equations of a circle 2. Oops. There we go. Okay. I can see it fine, but you guys couldn't. So, all right. Directions. We're going to jump right in here to a problem. We're going to find the center and radius all over again, okay, of our circle here. So, and I'll start with an example. We'll say x squared plus y squared plus 6x minus 10y plus 18 equals 0. So, this is the equation of a circle. But is it in that nice center radius format that we're used to? It's not, right? Womp womp. Okay. Any ideas about how we can take this and get the center and radius from it there? We know if we get it in this format, we'll have the center and radius, right? So maybe we should try and get this into this format. Some ideas about how we might do that here? Yeah, Emma.
Maybe if you put. Actually, never mind.
It's pretty complex. It's pretty complex. So like one thing we can kind of see here is the x and y's are all kind of mixed together. So we could like try and reorganize things so that like the x squared and the 6x are together, the y squared and the 10 minus 10y are together, and then that 18. That 18 we want to be over here, right? Because it doesn't really make sense to have a radius of 0. So let's move that 18 over, make it negative 18. Okay. So that like looks kind of better. Kind of better. Emma, did you have a thing you want to say?
And then you can pull out x and we get x on the outside and then in parentheses x plus 6.
Okay, yeah. So we could do this.
And then do the same thing
With
with the y.
the y's, yep, same thing. Factor out a y because there is a y in common there. So that's true. We can do that. So then can we say our center is at like negative 6, positive 10 here?
No.
Why not? What's the problem?
It's not like format.
Yeah, what's missing here? What's like, yeah, it needs to be a square, okay? So now we have a problem because like this quadratic, right, this like x quadratic equation here, right, this x quadratic equation here and this y quadratic equation here, we can factor them, but when they factor, they don't factor to be perfect square, right? This is not a perfect square, right? It factors to two things that are not the same thing, right? A perfect square, when you factor it, breaks down into two things that are equal, like right, 9 factors to 3 and 3, 81 factors to 9 and 9, right? So on and so forth. This is not a perfect square, okay? But we need it to be a perfect square. We need the factor to be a perfect square. Also, what's another problem here? Our radius is going to be what? Yeah, well, not a negative. R squared is negative, which means R would be what? If R squared is equal to negative 18 and you square root both sides, R will be what kind of number? Imaginary, right? And in this class, we're going to keep it real, okay? We're not going to worry about imaginary numbers. And so this really doesn't make any sense, you know, kind of thing. But we're not done yet because we still have some work to do over here too, right? So we're not quite done yet there. All right, so we need to take something that's not a perfect square and we need to make it a perfect square. And we're going to do that using a technique called completing the square. Yeah, okay, so we'll come back to this problem. Let's review completing the square. Okay, completing the square. All right. So again, the fundamental problem here is that we've got, and I'm going to make up a new problem here. Yeah, it'll look kind of like what we were doing there, but I'm going to take a step back, and we'll just start with a simple quadratic here. Okay, x squared plus 6x minus 7 equals 0. Okay. We're taking something here. So does this thing factor? Yes, it does. What does it factor to be? Negative. All right, so we need two numbers that multiply to make negative 7, add to make positive 6. So positive 7 and negative 1 make negative 7, and positive 7 plus negative 1 makes that negative 6, right? So these two numbers, right, they add to make this middle term, and they multiply to make that last term, right? So there we go. We got it, right? And we'll talk more about factoring this stuff later, too. But, all right. So it factors. But by the way that it factors here, does that mean it's a perfect square? It's not, right? X plus 7 and x minus 1 are different. So we have to do something else here. Well, let's take that x squared plus 6x, okay, minus 7 equals 0. Let's do it a little bit differently here. Okay. And we need to kind of like make it a perfect square. So right now that minus 7, it requires us to do the 7 and the negative 1, right? Those two multiply to make the negative 7 and then add to make the 6. So let's move that negative 7 over here to the other side of the equation and leave some space. So just like that. Okay. We added 7 to both sides, so these two things, right, these are still equivalent. They're the same. They're saying the same thing, same relationship. We're allowed to add the same thing to both sides, right? Okay. Now, we're going to try factoring this thing. Okay, and you might look at this and say, oh, we can factor an x out. And you're not wrong, but again, factoring x out is not going to create a perfect square. It's going to be x and x plus 6. That's not a perfect square, not what we're shooting for here. We want to create a perfect square. So we're going to factor it kind of like we normally would back when you first learned how to do this, right? We'll put the x and the x in front there. And we're like, okay, well, x times x will give us x squared. And then these two numbers, they're going to multiply with the x to make that 6. We have the extra stipulation, though, that these two numbers we want to add to make 6. They need to be the same so that we have the same factor here and the same factor here. So what two numbers that are the same add up to 6? So yeah, 3. So we're going to do plus 3 plus 3. Okay. So we're just going to make it work. Aha, now we create a perfect square. X plus 3 quantity squared. But is x squared plus 6x equivalent to x plus 3 times x plus 3? It's not, right? What is the x squared plus 6x missing? A 9. So we're going to just put in a 9. We're going to add 9, but of course I can't just bring 9 from nowhere, right? If I do it to the left-hand side, I also have to do it to the right-hand side. So I'll also add 9 over here. Okay, so we added that 9 in. And voila, we've created a perfect square. X plus 3 quantity squared equals 16. Okay. So, and we can, and now, not that we were asked to do this, but we could solve from here. But any questions up to this point? I'll pause right there. Any questions up to this point? Questions? You guys good there?
Yeah.
Okay. Okay. So at this point then, right, you can also still solve the equation. So just like we used to, we use normal factoring, right? Normal factoring to solve. We can say, okay, well, that's going to be x equals negative 7. That's going to be x equals 1. We can also solve using completing the square, right? At this point, if I wanted to continue to solve this equation, what should I do to both sides? Square root it. Okay, and so I get x plus 3 equals 4 or negative 4. Yeah, plus or minus 4. Okay, we have been ignoring that negative, the plus or minus part before, but that was because all those problems we did before, they were all in the context of distances or lengths. We don't want to talk about negative lengths. Now we're in a more abstract setting. There's not real context here besides just pure math. And so we want that plus or minus in there to show all the possible solutions, you know. And so we get x plus 3 equals 4, x plus 3 equals negative 4. And you get x equals 1 and x equals negative 7. Just like we did right there. Which should be what we get, right? Okay. All right, let's try another one here together. Okay, so again, complete the square. We won't worry about solving. Okay, so m squared plus 10m plus 14 equals negative 7. So does this thing even factor right now as it's written? Yeah, no, there's not two numbers that multiply to 14 but add 10, which is fine though. We don't really care about that. So again, first step here, I'd suggest moving that 14 over. Okay, leaving some space, so it'll be negative 21 here. Okay. I think we're going to fill in this kind of blank here and figure out what we're going to have to add in to make it a perfect square. Does anyone know right off the top of right off the bat what it's going to be? What do we have to add in here? It's going to be 25, yeah, okay. But let's see. Let's just make sure that's right. Okay, we're here in 25. So we have an m here. We have an m here. Let's check to make sure that they're right. Okay. So we know m times m will give us the m squared, and then these two numbers, this one will multiply with this m, this one will multiply with this m, and they have to add up to make 10. We need to do the same, so what's the number that's going to go in here? 5, right, yeah, 5 and 5. Okay, so m times m, m squared, 5m plus 5m is 10m, and then the last term, there's that plus 25. That's something you correctly identified there. Exactly right. So we're going to have to add 25 to this side. Okay, and so you get 4. And so m plus 5 squared is 4. Okay, questions on any of that? All good? Okay, so I'm going to have you guys try 2 here then, okay? So you guys try these 2 on your own. Okay, same directions, complete the square. So x squared plus 12x plus 20 equals 0. And p squared minus 8p plus 15 equals 0. Okay. So those 2, give those 2 a try. Okay. And then if you want to have something to ponder, if you finish quickly and want something to ponder here, think about how you might do 2p squared minus 8p plus 15. Okay, we can complete the square for that. So see what you can do. So this one, you'll notice like here is the exact same thing as here. So this one we did is we actually continued and solved for x. Here for this one we didn't solve for m. We just kind of left it. Because all the directions here really were just complete the square. But here we completed the square and solved it just to kind of see that you could complete the square. You don't have to. No. completing the square is just a method of solving quadratic equations. Most people don't use it though. But it's possible to. I see what you're saying. Let me think here. So first of all, you wouldn't, because do these two add up to make -8? So it needs to be the same number, and I mean exactly the same. So what do you need to make? Yeah. And then it multiplies correctly, so you still have the plus 16, okay, yeah. Yeah, so this one's a little bit trickier, isn't it? Because it won't be a perfect square now, right? Mm-hmm. Right, but remember, the goal for completing the square is to create a perfect square, and this is different than this, right? But now, there's a GCF here, isn't there? So why don't you take that out and then see if you get a perfect square. So some of us got this last one here too. That's good. If not, just an answer too. Like 30 more seconds. Yes. Yeah, so what do you have to add back in here to make this work out, right? Well, it's 4, but then okay, there's a 2, so it really should be what here? Yeah. Okay. All right, let's go over this here. So, let's go to Krem. You want to do one of these 3? You can pick whichever one you want. You can also pass if you want to, too, but just give me the answer is all you need.
I'll do the first one.
Okay.
Yeah. X plus 6 squared equals 16.
X plus 6 squared equals 16. Are we all good with that? Yes? Sounds good to me. Okay, sounds good to me. Well done, sir. Any questions on that one? Let me see it done. Okay, and again, you didn't have to solve them. If you went ahead and solved them too, that's fine, but really all I need is just completing the square. That's it. So well done. Okay. All right, let's go to Davina. How about you want to do the p squared minus 8p plus 15? P minus 4 quantity squared equals 1. Just like that? Okay. Are we all okay with that one too? Sounds good to me. Yeah. Okay. And then volunteers for this third one here? Someone want to give it a go? All right, Emma, what'd you get?
I got P plus 4 squared.
Okay, P plus 4 squared
Equals 1/2.
equals 1/2 like this?
Yeah.
Okay.
I got.
Okay. All right. Anyone else get something different? think they maybe got it? Okay.
2 parentheses p minus 2 parentheses squared equals
Negative 11, like that. Okay. Anything else? Yes.
I got the same as the second one except negative 7.
Negative 7. So 2 parentheses p minus 2 squared equals negative 7, like that?
Yeah.
Okay. Anything else? Okay. So, you think what? Mm-hmm. No?
I know what I did wrong on mine.
Oh, you think you made a mistake?
Yeah, because I accidentally put plus 8p instead of minus 8p.
Ah, so that would throw off your stuff. Yeah, yeah. Okay, so we'll throw that one out because. Okay, I gotcha. So that's between these two. Okay, so let's see here, right? Let's see. We can't obviously they can't both be the same, right? Because they're not exactly equivalent to each other. So well, let's see here. Where can I squeeze this? I guess I'll do it underneath because I don't want to go all crazy here. But yeah. Okay, so 2p squared minus 8p plus 15 equals 0. Okay, we can still take that 15 over. Okay, and leave the blank there. Okay. If we try and factor this as it's currently written, right? We can't just like make a 2 very easily there because we need this to be either 2p and then a p, right? Or this to be p and that to be 2p, right? To multiply this back to make 2p squared, we need one of these to have a 2 in front of it. But already then that's setting us up to not complete a square because this is different than that. But both the 2 and the 8, we can factor a 2 out of those. So let's pull a 2 out, leaving behind p squared minus 8p. Okay? Oh, okay. So you throw in the towel and you admit defeat. All right. Well, let's see if Gavin got it.
Wouldn't you pull out the 2 from the 8?
Oh gosh, yes you would. Yeah, I definitely messed that one up.
Okay, so my answer is still in.
Oh, still in it. Oh no, I already crossed it out. So hopefully you're wrong. No, I'm just kidding. But I don't hope that you're wrong. But we'll see here. I was wrong for sure there. Okay, thank you for catching that. That would have definitely affected things. Okay, so I pulled that 2 out. And so now we're going to factor this thing in parentheses. Bring the 2 along with it, right? We'll have p times something and then p times something there. Again, still equal to, well, we'll hold off on that for right now. Okay. Whew. Now we know what's got to go in here. What number's got to go in here? Negative 2, right? Because they have to add it to make negative 4, so we'll need 2 negative 2's, like that. And then because we have those 2 negative 2's, what number is missing right here? A 4, right? To make that a perfect square. Now, we brought in that plus 4, so to balance it out over here, what am I going to write?
8.
Why 8? I put a plus 4 here.
Is it 2 on the outside?
Right, that 2 is going to distribute with the 4 there, so I'm really adding a quantity of 8 over to here total, so I have to add an 8 over to here as well. And so it is going to be negative 7 there. And so we do have then 2p minus 2 squared equals negative 7. Okay, so Shifa, where did you get the negative?
I added 4 instead of 8.
Ah, there it is. Okay. Okay, good thinking though. Still almost there. Well done. Thank you for at least for doing that. Okay, and helping me out too with my mistake. All right, so there it is. So Gavin, well done there. Well done, sir. Okay. All right. Questions on any of those? We're going to go back to circles now. Okay. We'll go back to circles now. So now with circles, well, it's just simple. We're going to apply completing the square twice. Okay, so let's go back to our problem that we had. X squared plus 6x, I'm going to leave some space, plus y squared minus 10y, I'm going to leave some space, equals negative 18. I'm off the screen. There we go. Okay, we're just going to complete the square for the x's and do it for the y's as well. So we'll have x and an x like that, y and a y like that, equals, and then we'll hold on there. Okay. So with the x's, what number are we going to put in there in the parentheses? What do we need? A 3, right? A positive 3. Okay. And that means then what's missing right here to fix that, to make it fit? A 9, right? Exactly right. Okay, and then with the y's, what's going to go in the parentheses here? What two numbers are going to add to make that negative 10, but they have to be the same number? Negative 5. Okay, you may remember when you learned this in the past, you took your b term and divided by 2, right? So 6 divided by 2, that gives you the 3's. 10 divided by negative 10 divided by 2 gives you the negative 5's there. Okay, and then you also square them because they multiply out together. So we'll put a plus 25 in there. Okay, so that plus 9, balance it out over here. That plus 25, balance it out over here. Remember, that was us adding in stuff there. Okay, and so we get what? 16? Did I add that up right? And so I can finally, since it's x plus 3 times x plus 3, it's x plus 3 squared. And since it's y minus 5 times y minus 5, I can say y minus 5 squared. That's 16. Okay. So, Sammy, what is our center?
It is 3, negative 5.
Careful.
Oh, negative 3, 5.
There you go. Negative 3, 5. Yep. Mm-hmm. And the formatting is x minus h, y minus k. So you have to have minus h for it to be the h there. And then what's the radius? Go ahead.
4.
4. Well done, sir. Yep. Okay. Questions on any of that? Okay. Let's see here. Just want to see here which ones I did back. Okay, we'll do one more here together, and then I'll have you guys try one. Okay, one more together, and I'll have you guys try one. That's what we'll do. Okay. 3x squared, same directions. We're just going to find the center and the radius. Plus 3y squared minus 6y plus 15x plus 9 equals 0. So again, 3x squared plus 3y squared minus 6y plus 15x plus 9 equals 0. Okay, so what extra complication have I thrown in here that we haven't come across yet? What's an extra complication I've thrown in here that we haven't come across yet? What have I done here? So, Bella, do you want to say something?
Well, there's 2 different types of x's and
Okay, so we have x squareds and x's, y squareds and y's. Okay, yep, And we can rearrange them too if we want to put them in order too. So yeah, Jeff.
It's an odd number.
Okay, 15 and stuff like that. Yeah, so we might have some fractions and things. Ooh, right? We love fractions.
our x squared and our y squared have terms in them.
Yeah, coefficient. All right, Shifa, what were you gonna say?
GCF.
Say again.
GCF.
Oh, we have a GCF here. Is that what you're gonna say? 2 gamma? Yeah. Okay. So right, we got a couple things going on here. Okay, but right, if you go back to your circles up here, right, our circle formula, we do not have room for accounting for a coefficient here. But right, you recognize that in fact these are all divisible by 3. So we're going to divide both sides by 3 here. So I'm going to just divide everything by 3. Divide by 3. Okay. For circles, we need our coefficient of the square terms to be 1. Okay, so the coefficient for the square terms, we need those to be 1. And in fact, if you get to a situation where one square term has a different coefficient than the other square term, that's not a circle. Okay, by the nature of a circle, you're going to have the same coefficient here, and we need them to be 1, so we'll just divide through by 3. And I made it nice and easy with all these easily divisible by 3 things. So x squared, and then we'll also rearrange things to get them in the right order for us. And I'll also move over, well, it's now a negative 3 because I divided that 9 by 3. Okay, so just like that. Is everyone okay with all those steps I just did? I didn't lose anybody there, hopefully. If I did, let me know. We're good? Okay, so again, we're going to factor here and complete the square. Dividing by 3, that 15 became a 5, and now we have to figure out 2 numbers. They're going to add to 5. What 2 add to 5, they're the same thing. Yeah, 2.5, or I'm going to use 5 halves. Oh boy, fractions. Since we have these 5 halves here, what's missing from the previous line then? What do we need? 6.25, or 5 halves times 5 halves, which is 25 fourths. Okay, and so we'll add 25 fourths over here too. Okay. What's 6.25? All right, how about from the y's? What do we need in the parentheses there? A negative. Well, these two numbers have to add up to make what?
Wait, if you divide 6,
divide
you already got like
2. Man.
And I was just like, what?
Engage brain. There we go. Okay, so yeah, y minus 1. Y minus 1. That's right. Okay. And so then we'll add a plus 1 over there, right? And a plus 1 there. Okay. So let's see, that's going to be negative 2, but then that becomes negative 8 fourths. So negative 17 fourths. Positive 17 fourths. That's right. Negative 2, yeah. 17 fourths. Okay. So there's that. So we get, finally here, x plus 5 halves squared plus y minus 1 squared equals 17 over 4. Okay, so our center, let's go to Bella K. You're up again, Bella K. What's the center here then? Okay, so negative 5 halves, yes, and positive 1. There you go. That's right. And what's our radius going to be here? Go ahead, Bella, if you don't mind.
17.
What's that?
17 fourths.
So 17 fourths, remember that is our square. So what do we have to do to that 17 fourths? Square root it. So it'll be root 17 over 2 when you simplify it there. Root 17 over 2. And so there's our information. All right, questions on any of that? All good? All right, here's one for you to try. Last one. I'll get you guys started on your assignment after this. Okay, same idea. Complete the square to find the center and radius. Here we go. X squared plus y squared plus 4x minus 14y plus 4x plus 100 equals 0. So give that one a shot. Let's see what you can come up with there. One more minute. One more minute. One more minute. So, if the radius was imaginary, what would you say about the circle? There you go. Okay, so complete the square here, find that center and the radius of the circle. What we get for the center of our circle? What is it? -4, 7. Oh, okay. All right. That sounds pretty resounding there. -4, 7. And what about the radius? A imaginary radius? Right. So because we end up with taking the square root of a negative, like it's -35, right? Root -35 there. So the circle does not exist, we're going to say here. And because why? Because what do we know about the radius? The radius is what? Imaginary, right? Not negative. R squared is negative. The radius of the circle is imaginary. So the circle doesn't exist because the radius is imaginary. Yes.
If we had a question like this on a test, would you still want us to give the center even though the circle doesn't exist?
You don't have to, no. Yeah, once you establish the fact that the circle doesn't exist, then yeah, you don't have to give the center, because then it's like, how do you get the center of something that doesn't exist, kind of thing. It's like a philosophical question at that point. So, but anyway, does anyone need to see it done? We're all good? Okay, so results, right? This could happen, right? It just did. So keep that in mind, right? And I threw that at you. Good job there on taking it there. Okay. So that's it. That's all I'm going to show you for today. With that, your homework is posted on Google Classroom. I'll show it to you here real quick.